This is our first launch of a production design satellite system as part of our effort to launch a next generation broadband internet satellite constellation. This will be, fun fact, this will actually be the heaviest payload ever flown on a Falcon 9 rocket, weighing roughly 30,000 pounds. Each of those individual 60 satellites weighs about 227 kilograms or 500 pounds each. So while they're smaller than a typical communications satellite, they're still pretty sizable when you stack them all together. And that flat panel design maximizes space, allowing for a very dense launch stack, as you can see right on your screen right now, to take full advantage of that Falcon 9's launch capabilities. Starlink is also the very first Krypton-propelled spacecraft ever flown. Aside from being the native planet of Superman, Krypton also happens to be a nice blend of cost-effective and efficient propellant for ion propulsion. These ion thrusters enable the satellites to orbit raise, maneuver in space, and deorbit at the end of their useful life. The satellites also have a singular on-orbit solar array. This is one larger panel instead of two, which minimizes potential points of failure. Solar cells are standardized and easy to integrate into the manufacturing process. The Starlink satellites are also equipped with an autonomous collision avoidance system. To our knowledge, this is the first of any satellite constellation ever. The satellites use inputs from the Department of Defense's debris tracking system to autonomously perform maneuvers to avoid collisions of space debris and other spacecraft. This capability reduces human error, which allows for a more reliable approach to collision avoidance. In addition, 95% of all the components on the satellites are demisable, which means that when these satellites are at the end of their life, they will be naturally slowed by the Earth's atmosphere and ultimately be vaporized into dust as they re-enter. At 95% demisable, the satellites exceed current safety standards, and future iterative designs will go even further, shifting to a full 100% demisable material design. Also, while flying at a lower altitude of 550 kilometers, we ensure that the satellites will quickly and easily demise at the end of their life cycle. Once they reach the end of their life, the satellites will utilize their onboard ion propulsion system to deorbit over the course of a few months. In the unlikely event that a propulsion system becomes inoperable, the satellites will naturally passively decay because of atmospheric drag within 1 to 5 years, which is significantly less than the 25-year industry standard for low Earth orbit, or the thousands of years required if you're at a higher altitude.